Hi everyone, this is Dave Eberhardt with Dragonfly Engineering, and this week we're going to do something a little different. It's going to be a clips episode to basically summarize the mechanical design and manufacturing capabilities that I've done here at Dragonfly for the past few years. So enjoy the clips episode or the highlights reel, and I'll see you guys next week. Thanks for watching. When you're just running a lot of production like this with robots is basically the parts you're creating start to pile up and interfere with the robot. So that's one of the more common problems that you have with robot automation is what to do with all of the parts and to make sure they get out of the work area. See how it grabs the part off of the B side, grabbing the screw, and it pulls out and hands the part off to red. And this is, let's see, this is happening. So before I reset the counter, we're at 754. We've got 3,000 cycles to go, and the machine is telling me it's going to take 21 hours to finish. Yeah, we've got a ways to go, but the robots are working autonomously, which is not always a good thing. And I'm going to go back next door and continue machining the next mold. So say hi, Simon, to everyone.
Hi.
And so here is our new addition. This is a Kuka robot that I bought by a local e-waste company who posted an ad for selling these robots. So this is similar to the other Kuka robots that I use here at Dragonfly Engineering. And these two gears work together. So let's see if I can find that assembly. But here is the original, and then the mirrored part confirmed that they fit together in SolidWorks, which was kind of an important step because it would suck if I machined these and they didn't mesh very well. But the 3D raster here is one that you got to be a little careful with because you can plunge in deep into stock if you don't clear it out. But then you can see how basically the tool enters, comes up, and then starts a back and forth 3D profile, kind of like a 3D printer does, for our 3D surface. So we're machining the radius, the flat, and then the backside radius. Of course, that sheet metal's in the way. Let me pause. So I hit feed hold and spindle stop. Now I can open the door, and let's give you a better view. Actually, I'll clean up the window a little bit too. And then if I hit cycle start, it'll turn the spindle on and continue machining. And we'll see how it breaks off. There you go. This is our part. All right, so when I move the mouse around, you hear kind of that humming sound. But when I rotate, you can hear the video card actually transmitting either through space into the vacuum tube amplifier, or the amplifier is picking up noise on the electrical line from the video card. The amplifier, you know, these vacuum tubes, all right, it's time to do the CNC operations on the two ends of the piston rod. The first end of the rod is going to be the taper that is going to have the clevis pin hammered through. So it's the end that has the 3/4 inch to 12 taper on it, and an oval shaped 3/8 inch hole that Keith is going to hammer in his wedge pin in. So to do that, I've imported a DXF profile after I remodeled the shaft from the original drawing in 1932. So I've already written a program based on that DXF profile, and you can follow the tool step by step by turning the hand wheels. So this is showing how we're basically just facing down the 3D profile. And then the final operation, or the next to final operation, is the first finish pass. And now the tool is actually going to follow the true path after we've hogged out all the bulk behind it. So we've got a new addition to the shop here, and this is the Haas UMC 750 SS, which I believe SS means super speed. And this is a used machine that I purchased from a local company here through a dealer. I think I got a pretty good deal, assuming that everything works on it. Hello everyone, welcome back to Dragonfly Engineering. So this week we are going to start the exploration of Mastercam, which is the new toolpath program that I purchased, along with this new CAD CAM computer as well, which we built in a previous episode. So I've been going to some classes and teaching myself Mastercam, so I'm definitely still a beginner, but I think it's useful to show you guys a beginner's viewpoint of Mastercam. You're machining from all the way out here into your part, and to be perfectly honest, I think if we hide all of this stuff, then it won't actually account for this. But let's play with the linking parameters again. So Mastercam is just interested in the surface that you clicked as the finish, and then you can define top of stock to be bigger coming off of that. But we are using incremental. If we used absolute, let's see what happens there. Teach mode to automatic within a program. You flip the key and you just hit automatic here, but you got to be careful that you're not in the path of the robot, because it's going to be going if it cares if you're there or not. All All right, and then I'm gonna hit the play button, and you hold the play down until the robot gets to its path, which it is now. Oh, interesting. Oh, it did take the last part. Okay, so we advanced to the next car. All right, and the robot's operating at 50% velocity now. We'll see how it does. Here we go. It's almost like a bird throwing away the seeds out of the bird feeder it doesn't like. We'll stick all of this abrasive ceramic into the gas tank. So we probably will have some pits that are, rust pits in here that we got to clean up with this gnarly media. So we'll just drop this thing into the barrel.
Dude, you got the best barrels ever, dude. Just like you pull in.
And we'll turn it on. And then basically all of this media is going to be spinning around and like smacking the other side of the tank. In a continual like barrel action, and it'll get all gnarly and
drop down, snap,
and hopefully just bust off any extra flicks or of rust. But we hopefully we don't wind up with too much pitting inside.
And then after that, you just drop in, just ride the barrel and get pitted, so pitted like that.
I'm gonna put my foot on the base here. There we go. Back to Dragonfly Engineering. So this week we're going to cover mold cooling, which in the past I've said I don't always need to worry about using aluminum molds, but in some cases, for instance, the Game Tamer mold, which is a couple of large parts that take up a large amount of surface area of the mold itself, molded in polypropylene. Well, polypropylene is actually kind of a high heat capacity plastic. So when you set up to mold maybe 50 parts, it's not that big of a deal. But after that, like one round of parts per minute for 4 hours, the mold basically heat saturates and gets too hot. And what happens is you start to get defects in your part from the plastic not solidifying enough to be rigid enough to withstand the forces of ejecting the part out of your mold. Oh, look who's here. It's Sierra. Hey, Sierra. You want to say hi to everyone? She's pretty camera shy. What's up, doggy? All right, I'll let her off easy this time with the camera. Want to say hi? No? Okay. All right, so this is the molding side, and here we've got a plastic dryer right at the front door. And in here is the clean area where we've got a lot of the robots that assemble things. In fact, that molding machine over there is running automatic right now. Let's see if I can zoom in. And it's, I think this part is for one of my customers, a high volume part, and it cycles once every 15 seconds. Over here is the pool table / ping pong table / assembly table / shipping and receiving table, which is probably going to go to a storage area, or I'll sell it if anyone wants to buy it. But here's some of the Game Tamer product that we're molding on the dual shot machine. These are card racks, and then these are token trays, and I've showed this operation a few times. And they're back molding more because they're actually selling pretty good on Amazon. And it's all designed and made right here in the United States. Here's some polycarbonate lids that we got to be optimized. We had issues with silver streaks in the polycarbonate, which are basically long little bubbles, like stretched out bubbles. But we solved it by heating the mold way up. And then here's the back side of the dual shot molding machine. And of course we've got Big Yellow here. Big Yellow is going to be integrated into this machine, this molding machine, pretty soon. So it's going to reach in and grab the parts that eject off of the molds, which currently we're manually watching. But it's going to be better to have this machine or this robot grab the parts, confirm it has all the parts, so that we know that the molding machine won't close on a part in the mold. Oh, it looks like there's an air to clear. Probably it told us the back door was open. Okay, and then start. And there we go. We'll just make sure that this next shot is happy so their temperatures aren't too far off in a startup mode. Oh yeah, I think we kind of overdid it on the. I might have to throttle. Might have to throttle back on the cooling water a bit. All right, I'll do that while you guys are doing your thing.
Once the hot plastic starts going through it again, we'll
Yeah, it's just that we've got the chiller running too. So I'm gonna cut this back to 50%.
The signal source is.
Oh, okay.
Oh well, geez, Dave, it's not going to start without that.
You don't need that thing on there to run the engine, do you?
Only to fire the ignition. Okay. Well, I think that could be that problem solved.
I'll bet it'll start now.
At least it's capable of starting now. Yeah, so this has a signal coming off the negative side of the coil, and then it's got an inductive signal coming off the.
Oh, off the spark.
The spark.
Okay. Yeah,
Remember
that
the
clamp
old
right
ones
there.
used to have there was a spring that you would put in there
Oh.
between your wire and your spark plug, and then you clip to the
I think
spring.
that's the way mine is.
Yeah,
my dad's old one.
We're dating ourselves with it.
Before they figured out induction couplers.
Yeah.
All right, I'll bet it'll fire right up. There we go.
A little extra fuel now, I think.
That'll work it out. And then I will say manual release, which is another way of saying override the safety signal. So when I click this button and hit OK, the mold closes. And I need to make sure I turn that override back off. Otherwise, the molding machine may close on the robot because it will ignore the all clear signal if I don't turn that back off. Okay, so now we are molding. And you see we're cooling the part right now. The mold opens, the robot got the signal that it's clear to grab the part, and it pulls the mold core out of the mold. You see a little bit of a lift right there. And then we come over to the green robot, who then grabs, hands off the mold core, and then drops the mold core into the second mold receiver. And then you can see how it closes, and then the rubber is overmolded onto the polypropylene substrate. And here it goes through its little cycle of chilling. And then the mold opens. The green robot gets the signal after the ejection stops to come down and pull the part out of the core that was ejected. And we only eject on the second shot. And then the robot with its second claw grabs the mold core and then hands it back to the orange robot. And then over here, the robot drops the part into the bin, and then we continue the process. So that step right there where the mold closed is what I had to override for the very first shot. But now that we're in a continual operation, basically I can walk away. Oh, yeah, okay, we're still good. I was thinking I had a stuck sprue, but it was just doing its thing. Yeah, and then this will continue for the next 4 days. So let's turn the lights on and see how they're doing in there. All right, well, looks like they're still at it. Let's see if there's still a part in that part, or a part in that core. Yeah. So far, so good. mean, I would have known there was a problem if I saw the flashy red light. That's what I'm talking about. Now the molding machine opens, and here's our part. And we do a double stripper plate eject, and then the robot comes and grabs it, pulls it off. Now the mold closes, and you can see that pin is down, and now the screw is screwing down. You can see how it's screwing there. Okay, the molding machine is waiting for the input from the Arduino that says that the core pull features have pulled out of the cavity of the mold. And you can see how we're waiting to open the mold on the molding machine page. Okay, got the signal. So now our robot will come down and grab our part. And now we're going to follow the orange robot. The robot gives the signal to the molding machine, and it comes over here to clip the part. And does the pounce, and then the white robot grabs the part, they clip it. Orange takes the part or the scrap and dumps it into the scrap bin. And then it's back over here ready to pull the next part out. And then the second ejection is going to be simulated with our air hose, 100 PSI, and the green 2, which means go. So let's see what happens. With that looks nice. That way we eject the part off that's stuck on the stripper plate. So we got a 2-stage ejection here. So hopefully these will retract when I hit the blue button. Not quite. All right, got to work on that. everyone, welcome back to Dragonfly Engineering. So this week we're finally going to finish the tabletop for the robot work cell, and we're going to drill the 800 or so holes into the top of it, and we're going to use Big Yellow, the Kuka robot next door. And my wife April here is going to help me out with converting the G code for the milling machines that I normally write into a Kuka code that Big Yellow can understand. So would you like to show us how you do it?
Sure. Yeah, like Dave was saying, we're going to take G code and we're going to convert it into Kuka code. And I'm going to do that using Python. And after the data frame is made, I take a known header and a known footer, and then I take the data frame information and then I build out Kuka code. And then that whole segment is saved into a file and saved onto the C drive.
Oh. I don't know if the drill like that. Hey, this robot's a little too powerful. Oh, I see. It pushed out of the clamp a little bit. I don't know however many number of holes, 700 holes, at least pilot holes drilled, and it looks like the pitch looks pretty good.